Welcome to our journey into the world of great software. Have you ever wondered what separates average apps from truly outstanding ones? In this video, we'll explore the secrets behind writing software that not only works but also delights customers and stands the test of time. We'll follow real-world examples, meet some quirky characters, and break down the steps you can use to build amazing applications every time. Whether you're a seasoned developer or just starting out, you'll find practical tips and inspiring ideas to take your coding skills to the next level. Let's get started and discover what it really takes to write great software. Let's dive into our first example, Rick's Guitar Shop. Rick is passionate about matching customers with their dream guitars. He recently switched from a paper-based system to a computer app to manage his inventory. But as you'll see, even the best intentions can lead to unexpected problems if the software isn't designed with care. Rick's story will help us understand the importance of aligning software with real customer needs and how small design choices can have big impacts. Ready to see what happens when software meets rock and roll? Rick's programming team built him a shiny new inventory management app. The design looked solid on paper, with classes for guitar and inventory, and methods for adding and searching guitars. But as Rick started using the app, he noticed something strange. Customers weren't finding the guitars they wanted, even though he knew they were in stock. This scene sets the stage for understanding why good design isn't just about code. It's about making sure the software actually works for the people who use it. Despite having the right guitars in stock, Rick's customers kept leaving empty-handed. The search tool just couldn't find matches, even when the inventory clearly had what they wanted. This frustration is all too common in real-world software projects. It's a reminder that even small mismatches between user expectations and app behavior can lead to lost sales and unhappy customers. Let's see what went wrong and how we can fix it. What does it mean to write great software? Is it about pleasing the customer, following object-oriented principles, or using the latest design patterns? In reality, it's a combination of all these things. Great software satisfies the customer's needs, is well-designed, easy to maintain, and flexible enough to adapt to future changes. By understanding these core goals, we can set ourselves up for success in every project. To consistently create great software, follow these 3 steps. First, make sure your software does what the customer wants. Second, apply basic object-oriented principles to add flexibility. Third, strive for a maintainable and reusable design. These steps provide a simple yet powerful framework for tackling any software project, big or small. The first and most crucial step is ensuring your software meets the customer's needs. In Rick's case, that means making sure the search tool actually finds the guitars customers are looking for. This often involves gathering clear requirements, understanding user expectations, and testing the app in real-world scenarios. Only when the customer is happy can we move on to refining the design. Once the software works, it's time to make it flexible. This means looking for duplicate code, applying encapsulation, and using object-oriented techniques to keep your code clean and adaptable. For Rick's app, that involved replacing fragile string comparisons with enums and separating guitar specifications into their own class. These changes make the code easier to maintain and less prone to errors. The final step is to ensure your software is maintainable and reusable. This means structuring your code so that new features can be added with minimal changes to existing code. In Rick's app, this involved delegating comparison logic to the guitar spec class, making it easy to add new properties without rewriting the search function. Good design now saves you headaches later. Encapsulation is a key object-oriented principle that helps keep your code organized and flexible. By grouping related properties and behaviors into their own classes, you can make changes in one place without affecting the rest of your app. In Rick's case, moving guitar specifications into a separate class eliminated duplicate code and made it easier to add new features like 12-string guitars. Delegation allows one object to hand off responsibilities to another, making your code more modular and reusable. Loose coupling means that objects are independent and changes in one don't require changes in others. By delegating comparison logic to guitar spec, Rick's app became easier to extend and maintain, a hallmark of great software design. No software is perfect on the first try. Testing your app with real users and iterating based on feedback is essential. Rick's story showed how initial designs can miss the mark, but with careful testing and a willingness to adapt, you can turn a struggling app into a success. Always be ready to refine your work. Let's switch gears and look at another example, Doug's Dog Doors. Doug's customers, Todd and Gina, want a high-tech dog door that opens with a remote. The initial version works, but when Gina uses it, she finds a rabbit in her kitchen. This highlights the importance of gathering clear requirements and understanding how users will interact with your system. A requirement is a specific thing your system must do to work correctly. It's not just about what the code does, but about what the customer expects. Requirements should be clear, testable, and agreed upon by everyone involved. Missing or misunderstood requirements are a common cause of software failures. When software doesn't work as expected, it's easy to blame the user. But great developers dig deeper to understand the real problem. In the dog door example, the issue was Gina's fault. It was a gap in the requirements. By talking to users and observing how they interact with your app, you can uncover hidden needs and prevent surprises. Software development is an ongoing process. Each iteration brings you closer to the ideal solution. By gathering feedback, refining requirements, and updating your design, you create software that truly meets user needs. Don't be afraid to revisit earlier steps. Iteration is the key to continuous improvement. Visual tools like UML diagrams help you and your team understand the structure and flow of your application. They make it easier to spot design flaws, communicate ideas, and ensure everyone is on the same page. Don't underestimate the power of a good diagram in making complex systems understandable. Object-oriented analysis and design, OOA&D, isn't just theory. It's a practical approach you can use in any project. By focusing on requirements, applying OO principles, and designing for reuse, you'll build software that works, lasts, and delights users. The examples we've seen show how these ideas play out in real life. Learning to write great software is a journey. Slow down, do the exercises, and talk about what you're learning. Use visuals, tell stories, and engage both sides of your brain. The more you involve yourself in the process, the more you'll retain and the better your results will be. Even experienced developers can fall into traps like overcomplicating designs, ignoring user feedback, or skipping requirements gathering. Stay vigilant by regularly reviewing your process, seeking feedback, and focusing on the core goals of your project. Remember, simplicity and clarity are your allies. To wrap up, remember that great software is built on a foundation of clear requirements, solid object-oriented principles, and a commitment to maintainability and reuse. Use the three-step process. Satisfy the customer, add flexibility, and design for reuse. With these tools, you're ready to tackle any software challenge and create applications that truly rock.